All right, let's take a look at the graphs of a couple of basic trig functions, namely the cosine and the sine wave. We call these two functions periodic functions because the value of the function repeats itself every 2 pi radians. And to kind of think about that, I'll use the unit circle. And I'm going to label the points here on the unit circle on the positive x-axis, so the point 1, 0, on the positive y-axis, so this is the point 0, 1. Here we have negative 1, 0, and 0, negative 1. All right, so remember the unit circle is a circle of radius 1, and we know from our previous discussions that if I have the coordinates of a point anywhere on this unit circle, called the coordinates x and y, we know that if the point xy is on the terminal side of an angle in standard position, so, I could call this guy right here angle T. I know that x is equal to the cosine of angle T and y is equal to the sine of angle T. And that is true anywhere on the unit circle. So I can kind of use my four corners here, I call these four corners, to get a feel for what the graph of, let's start with sine, the graph of y equals sine t, what that would look like. So if I create a little chart here, the value of t, which is the angle in standard position, and I say let's take a look at the value of sine when the angle is 0 degrees, so that means coterminal with the positive x-axis. I know that the sine has a value of 0 there, and that's because the y-coordinate is 0 at this position. If I rotate in the positive direction, so remember that counterclockwise is in the positive direction, and if I rotate 90 degrees or pi over 2 radians, I see that now the sine of pi over 2 is 1. If I continue around the unit circle to pi radians, I see that the sine of pi is 0, and I can continue around. 3 pi over 2 has a sine value of negative 1, again as given by the y-coordinate here. And then I'm back where I started at 2 pi with a sine of 0. So we call the sine function a periodic function because the values repeat every 2 pi radians. And we say that the period of this function is 2 pi because it repeats every 2 pi radians. So I can take this table of values if I want and graph them here. And I have some graph paper with the x-axis labeled in pi over 2 increments. So I don't know if you can see this, but let me just make that clearer. So this is pi over 2. This guy's pi. This is 3 pi over 2, and then we have 2 pi. I can go ahead and plot points then to graph this function. All right, so to graph this, I'm going to use a kind of a bigger scale. Let's call this 1, and let's call this negative 1. And I know that, if I look at my table of values here, I know that when my t, so again, let's be clear. This is my t-axis, and this is the sine of t. When t is 0, sine is 0. So here's the point 0, 0. When t is pi over 2, the sine is 1. When t is pi, the sine is 0. When t is 3 pi over 2, my sine value is negative 1. And I'm back at 0 at 2 pi. So I can kind of sketch the sine wave like so. And this pattern will continue to repeat itself And and it also repeats itself going in the opposite direction here. So I can continue to show here that this periodic function does something like this, or looks something like this. And again, I can, I sketch this graph by simply using the unit circle and what I know about these nice, easy, neat numbers on the unit circle, the four axes, where the unit circle intersects the four either positive or negative axes. All right, and then if I wanted to, I could do a similar thing for cosine. I'll change colors here. So if I say, all right, let's look at t and then cosine t. All right, at 0 degrees, I see the cosine of 0 degrees is 1. At pi over 2, I see that the cosine value is 0. Again, I'm looking at the x coordinate. At pi, I see that cosine is -1. At 3 pi over 2, down at the bottom here, I see cosine is 0. And again, I start over. When I get to 2 pi, I start over at 1. And so I can go ahead and, if I want to, sketch this. So I have y equals the cosine of t, and I'll use +1 here and -1 here. So I see here that the cosine of 0 is 1. And again, I'm referring to the chart, which is no longer on the screen. So I'm going to plot these points. The cosine of pi over 2 is 0. The cosine of pi is -1. 3 pi over 2 is back to 0. And I'm back up to 1 at 2 pi. So again, we call the cosine function a periodic function because it repeats itself. If I were to continue the pattern, I would see it would repeat similarly, and it certainly repeats itself going in the opposite direction, like so. All right, so we call both sine and cosine periodic functions. We define the period of each as 2 pi. We can also talk about what we call the amplitude of both of these trig graphs. And the amplitude is the height of the peaks and the depth of the valleys. So in both cases, I see that the maximum value of our function is 1. So the amplitude of both of these is 1. And in upcoming videos, we will talk about transformations of these trig graphs and what happens to the graph when we change the amplitude and change the period and shift them up and shift them down.